Finally, we're on to solving rational inequalities. Our first example, we want to determine when x minus 2 is less than 8 divided by x. So if we look at the following graph here, remembering that x minus 2 is a linear function and 8 over x is our rational function, we can see that the y values for the line x minus 2 are less than the rational function from negative infinity all the way up to negative 2. And then again, from 0 all the way up to positive 4. That is when the height of the line sits below the height of the rational function. So let's look at this algebraically. The first thing I would do is move everything to the left side of the inequality sign. And again, this makes it a little bit easier to visualize. We have this equivalent expression, which if we graph, it's a little bit easier to see when this equivalent expression is less than 0. We can see it's from negative infinity again, all the way up to negative 2, and from 0 all the way up to positive 4. So again, we're looking for when this function is less than 0, when it sits below the x-axis. Next step is to create one term. We have three objects right now, x, negative 2, and minus 8 over x. So we need a common denominator of x. So I'm going to multiply the x by x over x, and the 2 by x over x. And we're left with x squared minus 2x minus 8 all over x is less than 0. Next step is to factor this expression. And this will help us determine when the function is positive or negative. The difference between polynomial and rational inequalities is that we must include the vertical asymptote in our calculations. So we see we have zeros at negative 2 and 4 and a vertical asymptote at x equals 0. So I like to call these my critical numbers. So setting up our number line, we need to look at the intervals from negative infinity to negative 2, from negative 2 to 0, from 0 to 4, and for anything greater than 4. So next up is to set up our interval chart. So we have x, again, less than negative 2, from negative 2 to 0, from 0 to 4, and for x values greater than 4. Our factors for this inequality are x minus 4, x plus 2, and the x from the denominator. Those three factors defined our function f of x. So again, we're going to call this thing here f of x. So all we need to do now is take numbers within the interval and test each of the factors. So for x less than negative 2, let's say I take negative 3, we'll have a negative, and a negative. So the function is negative within that first interval. From negative 2 to 0, let's say I take negative 1. We get negative, positive, negative. We see that the function is positive in the second interval. Third interval, let's take 3. So I get negative, positive, positive. So our function is negative in the third interval. And finally, for x greater than 4, we see that our function is positive in the final interval. So again, we're looking for where the function is negative, and we see it's from x less than negative 2 and x from 0 to 4, which matches our graph given here. So therefore, x minus 2 is less than 8 over x when x is less than negative 2 and when x is from 0 to 4. If we want to write that in interval notation, that would be from negative infinity to negative 2 and from 0 to 4. And our final example. So first step, let's move all terms to the left side. So I've graphed this function here on the right, and I want to see when is this function greater than 0, which is easy to see that it's going to be this component right here between the two vertical asymptotes at -1 and 3. However, the area that I boxed out here, this is one of those functions that actually cross a horizontal asymptote and come back down. So I've highlighted it here. I zoomed in on that area in this box below. And notice there's a second part where it is also above 0, which again in the graph it's hard to see unless you zoom in on that area. So let's solve this algebraically and see what happens. So now we need to find a common denominator so we can make one term. The first rational expression is missing an x minus 3 in its denominator, so we're going to multiply top and bottom by x minus 3. And our second rational expression is missing an x plus 1. So now what I have is x minus 3 times x plus 3 minus x minus 2 times x plus 1. That's our numerator. Denominator is x minus 3 over x plus 1. And we want to solve for when this is greater than 0. The bottom is factored, the top, however, is not because of this minus sign here. We need to get it all as one object. So what we're going to need to do is expand these quadratics and simplify and possibly factor. So what we get is x squared plus 3x minus 9, and then minus, don't forget the bracket here, x squared plus x minus 2x minus 2. We need that bracket because we're subtracting everything in that second set of factors. Bottom, we have x minus 3 and x plus 1, and still greater than 0. So let's simplify the numerator. The x squareds will cancel because we have x squared minus x squared. Here we have 3x minus 3x, so that is going to equal 0. In the numerator, we have x minus 2x, but we're subtracting this, so this is a negative x. Subtracting that is going to give us a positive x. And then we have minus 9 minus negative 2, which gives me a minus 7. So there's my numerator. My denominator is x minus 3, x plus 1. And we want to determine when it's greater than 0. So once again, we need to state our zeros and our vertical asymptotes. Let's set up our number line. So we're going from negative infinity to negative 1 to positive 3, and positive 3 to 7, and then 7 to infinity. So this helps us visualize our intervals. So let's create our interval table. So we have x less than negative 1 less than x less than 3, 3 less than x less than 7, and x greater than 7. Let's put in our factors. We have x minus 7 from the numerator, and x minus 3 and x plus 1 from the denominator. And remember, we're trying to focus on this function f of x. So let's set up our table. Next is just to pick some numbers. So first interval, I'll pick negative 2. So it's negative, negative, negative. And we see that first interval is negative. Next one, I'll pick 0, negative, negative, positive. And then you can finish the rest. So again, we're looking for when this is greater than 0. So we can see it's greater than 0 in these two intervals. So let's conclude. So again, I've shown you one way using interval notation and a second way using set notation. Here are a few questions for you to try, and good luck.